What's up, YouTube? Welcome to this part 2 of our SignalR worker services session, so series, if you will. Part 2, we are going to enhance, of course, what we did in part 1, and there'll be a part 3 and maybe a part 4, right? And of course, I think it's next week, is it? November the 14th. There's a live session. If you want to know more about that, I'll put a link where you can find more information about that meeting and the time and the link to the meeting, etc. In this video, we're going to enhance this part 1 code base. The part 1 code base is in my GitHub. You can find the link to that source code in the video for that part. At the end of this video, I'll put the link out on my GitHub for part 2. So whatever we've done today, you'll have access to that in my GitHub for the part 2 version. All right. So the basic plan for today's session is to enhance what we had where we left off last time. This time we want to add real world functionality such that we are listening to messages from a message broker, receiving those messages in our worker service, publishing those messages via SignalR to our browser. Last time we had a very simple way of doing it. We weren't doing anything real world. I'll probably show you what we did last time, because I need to also talk about some of the things I find people do incorrectly when it comes to worker services and SignalR and such. It's a bit difficult to kind of decouple yourselves from the SignalR, the way it's implemented in ASP.NET. And so it feels, for the most part, that people are simply writing the code in those classes, in the hub or in the worker service. And I want to spend some time today showing you a better way of doing this, and so that you can visualize how to disconnect or decouple yourselves from the hubs or the worker services, which are very, very ASP.NET kind of centric or dependent, and build a system that is kind of agnostic of these services, yet you're going to be able to use it, and that way you're not tightly coupled to ASP.NET, MVC, whatever you're building generally, right? So first I'll introduce to you what it is we had. Then I'm going to sort of talk about what we need to do today. And then towards that end, I'm going to then go into a bit of a design discussion with some slides to show you how I visualize systems, especially when it comes to things like the SignalR hub and the worker services, and how you want to keep yourself decoupled from these things. You don't end up writing all the code in there, right? Okay, so let's get started. So I'm going to run through the project we had so far. I have made some enhancements to the web pages in sort of to be ready for today, but I'll show you the functionality we had last time, and then the code behind that made that happen, and then that's the same code we're going to be enhancing. We didn't have these buttons. These buttons are probably going to be coming in part 2. We'll do some of the work for the buttons today, hook them up for the sending messages back to the server via SignalR. But last time we had these messages coming once a second, and messages were being displayed here through SignalR in the browser, and on the server side we had a worker service. Let's see that worker service. We simply had a loop in here, and this loop was publishing this message to the SignalR hub through this reference that we have in the worker service for the SignalR hub. So we have this notion of a worker service, and we also have a notion of a hub. You can imagine if you would receive some message from the browser, you would need to do something here. The question is, what is that something? And of course, there could be a lot of things in terms of, it's not just one line. There could be many classes involved in trying to get that thing done, that one thing done, right? And what I'm trying to show or talk about today is, you don't want to write the code here. I mean, you would write code here, but what you want is, you don't want this hub or that worker service having to be dependent on too many classes from your system, because you're effectively building the system inside the hub or inside the worker service. So what I want you to look at is a slightly different way of looking at things, so that you can decouple yourselves from the notion that there is such a thing as a hub or a worker service, because then you can use that system somewhere else to do the same functionality without being coupled to the worker service and the SignalR hub, if that makes sense. Okay, so I'm going to switch now to the PowerPoint. I'm going to try and explain that to you, how you probably see it, and then how you should see it. All right. Okay, so let me change my pointer. This is what we have today. We have got the ASP.NET pipeline. We've got the SignalR hub. We've got the worker service. These are fairly different, even though the worker service needs a reference of the SignalR hub in here, so it can then send messages via SignalR to the browser. But essentially, we want to have something called a subscriber. Maybe there's more than one subscriber, and the subscriber might have more than one dependencies and so on. And we want to be able to call or use that within the worker service, so that each time a message comes from somewhere else, some message broker, that message is routed through to the worker service, which can then send out the message through SignalR, right? And similarly, we could have the SignalR hub somehow have some dependencies, like I've shown here, the publisher. But in my mind, to me, and I'm going to shift to the next slide here. This is how I see the system. There's a system. It's a black box. I don't want to know what's in there. I don't know how many classes it's comprised of. I don't know how these classes are interconnected, how their dependencies work. Nothing. It's a black box. That system has an API. It can do certain things for me. So when I build a system, I'm building this black box. It can do certain things. The fact that it's running in an ASP.NET application or a console application or a WinForms application or a Windows service or what have you, it doesn't really matter. That system, the black box, is self-sufficient and can function if anyone we're going to call this API. It is not built around the fact that it's a worker service or a SignalR hub or an MVC application, whether it's a web API or it doesn't really matter. That system is a black box and it functions all by itself, just calling the API. It has no dependency. It has no correlation to the fact that it's being used in an MVC application, or web API application, or a SignalR hub, or a worker service. Does that make sense? Okay, so then, if this is your system, let's call it the system, the thing that you use to access that system, your MVC, your web API, worker services, SignalR hubs, WinForms applications, Windows service applications, Azure worker roles, web roles, so on and so forth. These are the SIL, or the service interface layer. All right? The service interface layer is simply a means to interface with your service. That's why it's called a service interface layer. It's a service interface layer. It's a layer that allows you to interface with your service. Now, I don't end up calling my systems services. I call them systems or applications. But the thing that I use to access that API of that black box is this SIL. I can build this entire system in a console application. I'll be just fine. So I'm not basing my implementation or the functionality on worker services or SignalR hubs or the fact that it's in a web API controller or an MVC application, right? It's built all by itself, standalone. We run in a console application, we written in a Windows Forms application. I can take that black box. I can move it and use it anywhere I want. I don't actually do that, but I'm designing for that idea so that I can ensure that I have a clean decoupling. So it's not like I'm envisioning possible scenarios. Oh my gosh, I could use it today in SignalR, tomorrow it could be somewhere else. No, I'm not actually doing that. I'm doing it, I'm going through that exercise. Sometimes it's a thought process, and it's just a thought exercise to ensure that my application, the system, this black box, is in fact decoupled from the SIL, the service interface layer. Okay, so in our context, what's the SIL? In our context, the SIL is this whole ASP.NET, the SignalR hub, and the worker service. It's all part of the SIL. And the system is everything else. The actual functionality is in the system. The worker services probably just allow us to run the system, if you will, and the SignalR hub allows us to communicate with the browser and to and fro. either through the worker service or directly from the hub. But the system has the functionality, which means the only dependency the worker service and the SignalR hub may need is your system. Now, that might sound a little weird. What do you mean that's the system? It's just like DLL? What class, right? So I'm going to go dig a little deeper now in the next step. If you understand this part, let's go to the next phase. All right. Now, in the system, so that's the system. All I've done really is I've just sort of given you an inside view of what's going on. And this is just one of the possible views. This is a fairly large system. It won't be the case in our smallish system here. But the idea is the same. There is one class, I call this the domain facade. This is the only class that is public. Imagine this black box to be an assembly. Now, if this is an assembly, the only thing you can see from the outside is this domain facade. You cannot see all of the other classes inside it. You have no reason to know how the system is working, which classes to call to do what things, what their dependencies are, etc., etc. So if the SignalR hub had a reference to the domain facade, it could call methods on it. And that's all it needs to know. It doesn't need to know what other classes. You see, the decoupling is going even further, meaning by putting a domain facade on the front, you're decoupling yourselves further from implementation, which means now if you look at over here, at any point in time, I can change the entire implementation of this whole part of the system. By refactor, I mean nothing has changed in terms of the requirements. So your requirements are still the same. All you're doing is changing the implementation. You're refactoring this implementation. The domain facade remains the same because the API is the same. The things that use your application are not impacted one bit because they didn't know about all these classes in here, so they know how to interact with them, so they're not coupled to them. So you're only coupled from the outside to this class. You're free to re-implement, change implementation, whatever you want to do internally here to your system without the knowledge or without the possibility of some consumer breaking because you refactored. This is a key aspect of the way I think about systems. In smaller systems, there may not be a domain facade. There may be just one of the managers. I'm not going to go into the details of what domain facade roles and responsibilities are and what the manager's roles and responsibilities are. That's a much more involved discussion. But I do want you to think in those terms. You can call them what you want to call them. The idea is the domain facade is simply the facade. Right? If you understand the English meaning of the word facade, it's the face you see. And that's the facade. You don't know what's behind it. And you don't want to know. I don't want to expose what's behind my facade. So I put a facade in the front so you can see this, and that's all you can see. That's all you know. And you can use this the way you can in terms of the public interface. And you don't know the implementation behind the scenes, allowing me to modify, refactor my implementation after the fact or over time. Right? In smaller systems, larger systems have more than one manager. In smaller systems, you might have just one manager. In smaller systems, I might say, you know what, instead of having the domain facade that talks to just the one manager, you might as well just have the one manager. Then you don't need a domain facade. So you might expose the manager in smaller systems, which we will do in today's system. It's very, very small. So we'll have a manager that's exposed, sort of outside, known by the SignalR hub and the worker service. And what the manager does internally, how it does, who it talks to, what dependencies it has, that's the manager's business. Right? The basic idea is to think of this black box, the system, as this black box. The system needs to function in and of itself. Something can call its API and the system can work. That allows you to test it, that allows you to use it in other places, but also allows you to ensure that that system is completely decoupled from the SIL, from the service interface layer. You don't want to be coupled to MVC or web services or worker services or whatever, right? You're building a system. The SIL is just one means to interface with your system. Make sense? Okay, so how do we do that? Now, I've written a lot of code to make it how I would do it in the real world. Very close to. Not exactly, but very close to. As an example, for anyone that's interested, this code is going to be up on my GitHub. The link you'll find in the show notes below. But today I'm going to only discuss the parts that you need to look at, even though there's a lot of code that's supporting it. so that I don't spend a whole lot of time explaining all the code and trying to get you to understand the way I would write a real world system. But the code is there. You can take your time to examine it. During this video, I'm just going to show you the parts and pieces you need to understand. All right. Okay. So let me see these other slides. Yes, for my mistake. In today's work, what we have is the system. Now, the system in this case would just be a folder. I don't go to the extent of breaking it down into an assembly and all that. To me, a folder could represent a folder, it could represent an assembly in the future. Because I have this other idea where dependencies are always one level down in the folder structure, never up or somewhere else. So I can literally take that entire folder and move it into a separate assembly because all its dependencies will be underneath it. But for the purpose of this application, a folder is the system that contains this, the system that has a manager. And the manager is in turn talking to a subscriber, a publisher, the config provider. The only reason I have the config provider here is to support the notion that we can switch from service bus to RabbitMQ as the message brokers. And that'll give you that other kind of way of understanding how to do that. In today's implementation, I have the RabbitMQ version that I'm going to show you. I'll probably also show you the service bus version, but nonetheless, the service bus version, our implementation will be available in the source code. It's the same because you need your own service bus connection or Azure account if you want. But RabbitMQ is for free. There's a Docker image. If you look at my message brokers series, you'll see that I've published links to a Docker image that allows you to very, very quickly install RabbitMQ on the local machine and get started up and running. The code for the brokers and the publishers is very similar to the adaptive design pattern video. I'll put the links to all of these videos up here. So if you want to kind of do it by yourself but need a little bit of help, you can look at the adaptive design pattern. The publisher and the subscriber there are pretty much what I've used over here with some changes, of course, to suit this project. All right. So as I said, we have this message broker publisher worker that has a context or as a reference to the hub context. And we use this hub context to send all of our clients a message every 1 second. Yes, we're going to change this to essentially get access to our actual message broker. I have a RabbitMQ, this is running on my local machine, and it's going to be publishing these event messages to receiving these event messages from some other application that I'll talk about. But I want to hook this up, right? So the thing is, I don't want this here. This was just a kind of stand-in. We need the real code. In this project, we have also what I call the services, and within the services, there's the SignalProcessor. So this folder here is the system, and that might seem like a whole lot. It is a whole lot because I'm trying to make it a little more the way I would build applications in the real world. Of course, we only need the message brokers, in this case, the subscriber. That's going to be going into our hub here. But the subscriber, if you remember, our system, only the facade, if you will, is available to the publisher, the worker services, and the SignalR hubs. And that's the manager. In this case, I don't have a facade, domain facade. I'm using a manager. I've set up some constants here for the topics and queues or exchanges and queues for the message brokers. I've got some settings coming from the config system, and here. So what we want to do is we want to start listening. This is the way we sort of start up the system, if you will, bootstrap the system, and it needs a callback that we have to send it, as we have to call it to tell it, whoever's calling us here, as to what came back. And effectively, there's a event message as part of the arguments, and it returns a task, so typically asynchronous. So essentially, this callback thing is saying, whoever's calling us saying, hey, start listening, but each time there's a message, please call me back at that callback, passing me the message that you received. And you can imagine then in our worker, if we were to start it here and we said, please call me back here, then the worker service itself could publish using something like this, the event message that it receives. Okay. Now, all of this code that you see here and in other classes would have actually ended up in the hub or the SignalR hub or the worker service, because that's the functionality you require. But you don't want to build it all into the hub or into the worker service, right? You want to decouple yourselves from that. This is now the manager in this case is just a class. You knew it up and you got access to all the functionality you want. How it does it, what classes it uses, what dependencies it has, don't know, don't care, right? Okay. So in our broker, in our worker service, we can just remove this. And here we just simply have to write some simple code like that. So we new up our manager. We have an instance. We start listening. And to give it the callback, we're just setting up a callback here. This callback, as I said, it receives a event message as an argument. And it's task returning, so it's asynchronous here. I'm awaiting it there. And I'm basically doing the same line we had before when you're in the while loop. So this is this is exactly the same. All I've done is I've delegated the listening to actual messages from an actual broker to this manager. I don't know what it does. I don't know what classes it uses and how it's doing that. I don't want to be coupled on the service interface layer side. I don't want to be coupled to the system. On the system side, I don't want to be coupled to the SIL, right? So both are wanting to stay away from each other. They just need that bare minimum contact, in this case, that one method, and get it done. What all you need to do, and where you get your settings from, and what classes they're using, not my business. I'm going to take the data you give me, and I'm going to publish it to the browser. That's it. That's my job as a worker service here. And I'm going to keep you alive, basically, right? Because I'm a worker service. So I'm going to keep that manager alive. And I'm going to, every time an event comes back from it, I'm going to publish that message to the browser. I don't need to know any more details than that. Right? That's decoupling. So now that we have this, assuming I've done everything else correctly, let me just make sure my Docker is running. Yes, it's running. I've got my Rabbit instance also running, since it's stopped, which means it's running. And what I can show you is just to browse to Rabbit. Oh, get me to log in. So I have one exchange created for this project, and I call it, it's the YouTube vhost, and it's called titles.events.topic. And there are some queues. Some queues are even bound dynamically, meaning these are queues that are created dynamically by the application that wants to subscribe, saying, hey, this is me, please subscribe me to this exchange or topic. I'm calling them topics here because I'm supporting both Service Bus and Rabbit. In Rabbit, things are called exchanges. In Service Bus, they're called topics. So I call them topics here. Whereas in Service Bus, the queues are called subscriptions. I don't like that word because too overloaded in Azure itself. Everything is a subscription. You don't know what you're talking about. So I prefer to call things queues. That's the Rabbit terminology that I've sort of moved forward in both ways. So I call queues, but I call exchanges topics from Rabbit's point of view. This is really an exchange, but I call it a topic. And then there are queues here. And I have this title.events.queue. But then also this title.events.queues. This is my desktop. So I dynamically subscribe and do that. So even if I deleted this queue, it'll be recreated. And you can see that the code is there in the code. I'm going to I'm in the queue. So I should be able to delete the queue now. Oh, delete. Right. Okay, so now it's deleted. And of course, the application that we're going to be building will dynamically create the queue and then publish messages, receive messages, or SignalR, the manager, right? All right, so it looks like we're up and running. So the thing is that, so if we keep this running, at this point, there are no messages coming in, so it's going to sit and wait. Okay, so it's going to wait, no messages. Now, if you look back at our SignalR, sorry, our RabbitMQ, you should see that in the queues, it's recreated the queue. Okay, so it's waiting. This application has created this queue. It's waiting for messages to arrive on this exchange or this topic here. We need something now that will publish messages to this topic. And the message, of course, have to be this event message as we have. Let's look at that event message for a bit here to refresh ourselves as to what this data type is. It could be any data type, honestly. I'm just trying to keep it simple here. So that's what our event message looks like. It's got an ID, it's got a title, and a date time. Very, very simple. It doesn't have to be so simple, but in this case it is. And the only reason I have the default constructor here is it turns out that the .NET Core JSON serializer does not support immutable classes when it comes to deserializing. It needs a default constructor. And so I had to modify this class to do that. I've all known it. I just keep forgetting it. I'm hoping this is implemented in support one day. I think in .NET 5, they do support that now. And I had to make these properties rewrite just so it can be deserialized. Okay. So this can now deserialize messages from our message broker and then move them and publish them into our browser. All right. So now the question is building an application that publishes messages so that we can receive them in our SignalR based browser application. All right. Let's do that. I'm going to keep this running and I'm going to start a new application. It's just a console application. Again, there's a bit of code here. I don't want to kind of spend all the time on this video showing you all the code. The code for this will not be available on my GitHub yet because this is what we are going to be building during the live session or something like this plus something else. So I want, if you're interested, you can use the source code for the SignalR project and then accordingly build a publisher, if you will, that publishes these messages to RabbitMQ or Service Bus, and then you receive them in the SignalR side. The SignalR, that application is built to support both Service Bus and or RabbitMQ because you need a connection string, you need an account, Azure account for Service Bus. For the live session, I might make one available. So in case you don't have one, we can all party on the same Service Bus. But if you want to develop, you can develop them locally using RabbitMQ, right? All right. So I have some extra, let me zoom in so I have some code in here as well. I've got the message brokers and all this sort of thing that's required to do the publishing. There's the models, which is very much the same as the event message we saw before, except this one can be immutable because we are not deserializing here, we are serializing it. And there's a message class. This might become important just generally, where the body is the serialized version of the message. If this is not clear, don't worry about it. This part, the actual publishing and subscribing part, I have explained quite a bit and code for it, much simpler code for it in my adaptive design pattern video. That's part of the series of the message broker series. Take a look at that code or look at the video. That explains this whole polymorphic behavior and use of RabbitMQ versus Service Bus. You can just easily flip between one and the other. And this is a class that helps, one of the classes that helps us do that. And so I won't be going into details here. But the idea is here in this program CS, we want to be able to start publishing messages when we start this application up or if you press a key or something, right? So we need to start publishing messages to the same message broker to that topic, and subscribers will then receive that message, right? Now, what I have here, I have about 500 different random titles of names, movies, books, whatever. There's just 500 of those. So we're going to be publishing these things from here. So the first thing to do is to read that file, this file is local here. Read that file and sort of read the lines and publish the lines, from here, right? So to do that, what we're going to have is a method given the file name. This is going to simply read line by line and stream it out. If you remember my streaming video on C#, not C# 8 streaming, but C# streaming. There'll be a link over here. Take a look at that. That's what I'm doing over here. I'm streaming the lines one at a time as I'm reading them without having to load up the entire file before I can return the data. And I'm only maintaining one line in memory. All right. So, and then over here now we need to call this thing in a for each, and then for every title that we get from our file here, we're going to publish that title to our publisher. Right. So let's do that. So I have a message broker factory here that is just given the type of message broker is going to give you a publisher. So over here, you don't know whether this publisher is a RabbitMQ publisher or a source bus publisher. You don't care. Don't want to know. And then it reads the file here and it passes that to this method. It gets back titles. And then for every title, it sets up some information just in order to be able to send that message or publish that message. It serializes the event message itself to this JSON. Then it constructs this message, not event message, but message. As I said, the message bytes is part of the message here, but the message ID and application JSON, some other things are there. None of this is required. I just happen to design it like this. But that's, I suggest you to go down a similar path, the way I've described in the adapter design pattern video and the source code. And publish the message. That's it. So if you start to publish the message, our browser here should start to receive the messages, right? So let's see if that is actually true. Now, before we just run through this, maybe I should have a I should say press enter. Okay, so we started up as we're going to see that. We hit enter, it's going to run through that super fast. It's going to zip through it. Okay, so this is running. I'm just going to minimize this. We can see that browser in the back. All right, so RabbitMQ is up and running. And this is going to be publishing messages super fast. We're not printing anything out here. We're just going to see a flurry of messages appear over here. And there's 500 items here. So it's going to be 500 items here in almost no time. All right. So 1, 2, go. That took 2 clicks. Okay, it's done. Let me try it again so you can see it. Takes me 2 clicks to have moved away from here. Okay, I don't know if it's going to happen now on the first click or 2 clicks. Okay, and now I'm going to click. So it's 500. It should reach 1,000, right? Go. That's it. Done. So if you want to slow this down, then it's a matter of putting a delay in this loop here, so it doesn't end up going so quick. So we could do this is asynchronous. So we can say task.delay here, and have it a delay of 1,000. And now we can run this again. And now it's going 1 second at a time. Right? The key part really was, I was trying to show you, I've seen this a lot, and not just in SignalR applications or worker service applications. Yeah, I've seen this in MVC applications, web API applications, that the system is kind of intertwined into the MVC-nesses and the web API stuff. And it's like, you cannot separate out the system from the SIL. So one of the big focuses I had today was to show you that you don't need to couple yourselves to the SignalR hub or the worker services or the web API controllers or the MVC controllers. You need to look at your system as a black box that is separate from the fact that you happen to use it in a web API application or an MVC application or within a SignalR hub or a worker service, right? You don't need to couple it. The system can then front or surface some facade. I call it a domain facade, domain meaning business, domain facade. And so that's the facade. this is what you see. What my system can do, very clear over here. The facade is not doing anything, by the way, but from the outside, it seems like it's doing it, right? Because all you know is this one. The facade in turn is delegating all the work to other classes and so on and so forth. So there's no kind of problem there. But everything your system can do is visible in this public class. And that way, your consumers of your system, your black box, just know the facade. And they don't need to know what class to use internally. If you're using class A, class B, class C, what that dependencies are, its dependencies are, oh my gosh. It'll be a blooming nightmare to work with a system like that in an MVC application, right? Or any application, console application. I should be able to just new up my facade or manager. Just new, blah, and go. As you saw here in the, let me just shut this down. I just newed up this thing and I use it. This class and all of this is the system, is configured, is configurable, is testable. There's no difference there. But it does not expose its internals to the outside. It is a black box. By black box, that means you can't see through it. A white box, you can see through it. And because it's a black box, I don't want to know at this point when I'm here sitting in the worker service, how it works, which class to use, how does it do the publishing? Don't want to know. I'm saying here, I want you to start listing, oh, and by the way, whenever you receive a message, please call me back here. Because this is like a UI function, if you will. The fact that it needs to take that published message and publish it to a UI is the function or responsibility of the UI. And so the black box provides it with that interface saying, okay, I'm going to do all the heavy lifting of figuring out the service, which topic, queue, all of that. You just tell me, where should I call you when I have a message? And it says, call me here. And that's that. Okay. So that's what I was really trying to show you is that this class, now you could say I can inject this through dependency injection in from the ASP.NET Core, but that, yeah, to me, that's irrelevant, whether you inject it or create a new instance here. There's only one instance. It's not like there's multiple worker services being created. There's just one anyways. Now, in the next version, we are going to be requiring to modify the hub, the SignalR hub that we haven't touched yet. And that is when I'm going to show you some of the code now with regards to the browser part of things. We'll hook it back to the hub. We'll see it just being received here, but then we're going to stop. I don't want to actually write the code for that. We're going to do that during the live session where we can have somebody write that code or all of us write that code and plug it all in and then write that publisher that I showed you earlier and have that work and actually I'll show you when you see the UI, there's 3 buttons called red, green, and blue. These actually turn lights on and off. They don't want to do that today. But on the November 14th, in the live demo or the live coding session, I have a device with the red, green, and blue lights on it, actual bulbs, like real, high voltage bulbs. And by turning these buttons on and off in the browser here, you'll be able to turn on and off lights in my hand, no matter where you are in the world. All right, so that's the kind of one end goal of that. So I'm going to show you the UI for that in terms of you've seen the UI, but I'll show you the hooking up for it. So what we have is these 3 buttons and they have this on-off concept. So red light is off, and it's on, off, on, and same for the green. But every time I'm doing this, I'm firing off events, or I've captured these events. And these events are calling back through the JavaScript thing. Let me show you the JavaScript here. I've got this checkbox color. They're all called, the name is checkbox color. So they all fire events here. And then they have a state on or off. And they each have a data.light color or attribute. I get the light color. And then the idea is through the SignalR connection, I want to invoke this command called command received. So this is now going to look for a method on our SignalR hub called command received. And it's going to require 2 arguments, that method. So let's go create that. So in our hub, And what is the light color and state? We don't need this. Let's put a breakpoint here. I need to return. You could also pass in a DTO that contains all those properties. It's not like you have to break it up into separate parameters. I guess it's the same problem here. Apparently not. Oh, it stopped here. Okay, so we can see here, we got the red, and we got the true. And so red is on. Let's turn on green. And we see green and true and so on. So I just wanted to hook up the stuff for you today in this video, not spend all the time. Again, here, if you remember, this is the SignalR hub. We don't want to write all our code in there. So we will use our manager there as well. Now you might wonder, Shiv, do you really want the manager to create his own instance and the worker service to create his own instance? Do you want to make your manager a singleton, or do you want to use dependency injection and register it as a singleton and then have it available to both the hub and the worker service? Either way is fine. I'm not opposed to using the dependency injection in .NET Core to get this part done. I just don't use it in my system. My system is sacred to me. The SIL is whatever the SIL demands, right? In .NET Core, Web API, you are required to use, dependency injection to do all the stuff. I'm okay with that as long as it does not encroach into my system. My system is sacred, that black box. All right. So now remember the date once again. It's November the 14th, which on 9 a.m., sorry, or 10 a.m. I forget the date. I think it's 9 a.m. EST. It's going to be a live session. If you have worked with the source code I put out last week and this week and now, then you'll be in a good shape to sort of be more effective in the live session on the 14th. If you've already built the client side and things like that, you'll be in very good shape. Aim is to build the client such that you have a button here that says start, and that's when the client starts to publish messages. Then we see the messages here, and then we'll use the red, green, and blue buttons to trigger off the device that I'll show you, that turns on real electric light bulbs, red, green, blue light bulbs. You can control those light bulbs from anywhere in the world. All right. I hope to see you all there. I hope you enjoyed this video. If you have, please give me a thumbs up, and I'll see you next time.